Good evening, everyone. Welcome to the session number 22 from the chapter of Electromagnetic Induction. The topic for the today's session is the calculation of induced EMF, and based on this topic, I have selected one question for this session, which was asked in the JEE main exam this year in the month of January. So the question here is a circular loop of radius 7 cm is placed in a uniform magnetic field of 0.2 Tesla, which is perpendicular to the plane of the loop. Now this loop is converted into a square in 0.5 seconds. So the induced EMF in the loop is. So here we have four options and we have to find the correct option. So as per the Faraday's law of electromagnetic induction, the induced EMF is equal to minus d phi upon dt, where d phi upon dt is the rate of change of magnetic flux. So in this question, we will first of all find the magnetic flux which is associated with the circular loop. And the formula for the flux is BA cos theta, where theta is the angle between the direction of the magnetic field and the normal to the plane. Now, since the magnetic field here is perpendicular to the plane of the loop, therefore the direction of the magnetic field and the normal to the plane will be parallel to each other. So in that case, theta will be equal to 0 and cos 0 is equal to 1. So flux, the magnetic flux will be equal to B into A. Now the value B is the intensity of the magnetic field, which is equal to 0.2 Tesla. And now in the first case, we will find the magnetic flux which is linked with this circular loop. So this will be equal to 0.2 into now the area of the circular loop, which is equal to pi r square. So pi is equal to 22 by 7 into 7 by 100, because the radius is in centimeters, so we will convert it into meters. So this is equal to 22 by 7 into 7 by 100 into 7 by 100, and this is equal to, this 7 and 7 will get cancelled, and 0.2 into 22 into 7, this is equal to 22 into 0.2 into 7. Okay, this is equal to 30.8 divided by 10,000. So this is equal to 0.00308 Tesla meter square. Now the flux which is associated with the square, this circular loop is converted into the square in 0.5 seconds. So the flux which is associated with the square will be equal to 0.2 into the area of the square. Now this circular loop is converted into a square. So first of all, we will find the circumference of the circular loop. The circumference is equal to 2 pi r, 2 into 22 by 7 into r. R is 7 centimeters, so I have converted into meters. So this is equal to 44 by 100. This is equal to 0.44 meters. So the length of each side of a square will be equal to the length of each side of the square. Let us say this is L, so this will be equal to 0.44 divided by 4 meters, and this is equal to 0.11 meter. So the area of the square will be equal to 0.1 whole square. So this is equal to 0.11 whole square. So and its value will be equal to 0.11 into 0.11 into 0.2. So this is equal to 0.00242 Tesla meter square. Now we have to find the this rate of change. Now here induced EMF is equal to rate of change of magnetic flux. Now this circular loop is converted into a square in 0.5 seconds. So the rate of change of magnetic flux will be equal to the change in the flux divided by the time interval. Now the change in the flux is equal to this is equal to minus d5 upon dt, and this is equal to minus, and this will be equal to 0.00242 minus 0.00308 divided by 0.5. So this is equal to divided by 0.5. This is equal to 0.00132 volts. So this is the value of the induced EMF in volts. Now we have to find the value in terms of this millivolts. So in terms of millivolt, I will simply multiply this value by 1000. So this is equal to 1.32 millivolts. So the induced EMF, which is equal to the rate of change of the magnetic flux, that is E is equal to minus d5 upon dt. So this is equal to minus. So the change in the magnetic flux is equal to 0.00242. So this was the magnetic flux which was associated with the square loop, and this was the flux which was associated with the circular loop. So this was a change in the flux, and the time taken for converting this circular loop into the square loop was equal to 0.5 seconds. So the rate of change of magnetic flux will be equal to that is the difference of these two magnetic flux divided by the time interval. So finally we have got the value as 1.32 millivolts, and the correct option here is B. So thank you very much for joining this session. In the next session, I will be coming up with a different type of a question from the same chapter of electromagnetic induction. And so till then, have a nice day. Bye.